Which connection of transformer allows the zero sequence current to flow? A. Y connection with solid or reactance grounding. B. Y connection with no grounding. C. Delta connection with no grounding. Time's up. The answer is A. Y connection with solid or reactance grounding. Any connection of transformer with any type of ground would allow zero sequence current to flow. Why do we only have positive sequence current in a three-phase to ground fault? A. Because it has ground. B. Because it is symmetrical fault. C. Because it is unsymmetrical fault. Time's up. The answer is B. Because it is symmetrical fault. Negative and zero sequence current occur in a case of an unbalanced fault, while three-phase to ground fault is symmetrical, balanced fault. What is the relation between sequence currents in case of single line to ground fault? A. All sequence currents have equal magnitude. B. Zero sequence has different magnitude. C. All sequence currents have different magnitudes. Time's up. The answer is A. All sequence currents have equal magnitude. One of the characteristics of sequence currents is that they all are equal in magnitude. How are the sequence networks positive, negative, and zero modeled in a sequence circuit in case of a single line to ground fault? A. All sequence networks are in parallel. B. All sequence networks are in series. C. Positive and negative sequence networks are in parallel. Time's up. The answer is B. All sequence networks are in series. In single line to ground fault, zero sequence current equals positive sequence current equals negative sequence current. As all the three sequence currents are equal, the sequence networks are represented as a series circuit. Why are the voltages in unfaulted lines are out of phase in case of single line to ground fault? A. Because the voltage of phase with no fault is zero. B. To maintain the phase balance. C. Both. Time's up. The answer is C. Both. One of the lines in a single line to ground fault is shorted with ground, resulting in zero potential. As a result, the other two line voltages become out of phase in order to preserve phase balance. What are the values of voltages in case of single line to ground fault? A. Same volts for unfaulted phases. B. 0 volts for faulted phases. C. Both. Time's up. The answer is C. Both. When one of the lines is shorted with the ground, the voltage at the line becomes 0, but the unfaulted lines have the same magnitude but are out of phase with each other. Why do we only have positive and negative sequence in line-to-line fault? A. Because the phases are short-circuited and current circulates. B. The fault is not grounded. C. No specific reason. Time's up. The answer is B. The fault is not grounded. In faults involving the ground, zero sequence current occurs. Example, single line to ground or double line to ground. As in the case of line-to-line fault, there is no ground involved, so it does not have a zero sequence current. Fault current in both the line in a line-to-line fault have A. Same magnitude, opposite phase. B. Same magnitude, same phase. C. Different magnitude, same phase. Time's up. The answer is A. Same magnitude, opposite phase. As a result of a line-to-line fault, two lines become shorted. As a result, the current's shortest path is to enter one line and depart the other, resulting in fault currents that are identical in amplitude but out of phase on both lines. How are the sequence networks connected in case of line-to-line fault? A. All in parallel. B. All in series. C. Positive and negative in parallel. Time's up. The answer is C. Positive and negative in parallel. The positive sequence and negative sequence voltages are equal in line-to-line fault, represented as a parallel combination in sequence network. Why are positive and negative sequence modeled in parallel in a line-to-line fault? A. Because of a closed path. B. Because both currents have the same magnitude but are in opposite direction. C. None. Time's up. The answer is B, because both the currents have same magnitude but are in opposite direction. In line-to-line fault, there is no zero sequence current, and positive and negative sequence current is in opposite direction. Also, the positive sequence and negative sequence voltages are equal, which satisfies the condition of parallel connection of the two-sequence model. Hi, I hope you enjoyed this video and found it useful. Comment below and subscribe to our YouTube channel so you can get updates on whenever we post new content. Thank you and see you next time.